Hi, everybody back. Welcome back to the Chicago Statistic Lecturing Series and under the unit random variables and distributions. So previous video, we start to talk about the joint probability distribution and joint CDF, for the discrete random variable. So for this video, we're going to talk about the continuous random variables, how to find the joint PDF and how to find the joint CDF if your random variables is a continuous type, all right? Okay, so just like the discrete one, every rules for the single random variable will follow for the the more than one random variables here. Okay, so let's take a look. Let's go to the whiteboard, do a very brief review what we did for the single random variable here. Right now we can go back here. So just try to refresh your memory. So for the single continuous random variables here, right? So the PDF, right? So if you remember what is the PDF, it's a probability density functions, right? So we used f of x to represent, and the x is a continuous type of the random variable, and then the domains here, if they did not specifically say, we'll say the domain is from the negative infinity to the positive infinity. And so we said the first thing is we say, how do I find the probabilities here? So if I want to find a probability from A to B, and also remember, because this is continuous, you have equal sign or you don't have equal sign, really does not matter, right? Because when the x is equal to one fixed number for the continuous random type of variable, it's 0, so it doesn't matter. So just like we did in the calculus, this is really just try to integrate the f of x, right, from the A to B here. So if your function is here, so if this is your, for example, this is your PDF, right? So this is f of x, this is the PDF. And then if you want to find the probability between A and B, basically you integrate it. So you find the area, between these 2 points. Okay, then we also talk about the CDFs, right? So the CDF, we use what letter? We use a capital letter f of x. So the way we defined the CDF, we said capital F of x is equal to what? It's from the negative infinity to the x, and this is f of the t dt's here. That's how do we define the CDF here. So for the CDFs here, right? And then we know by the fundamental series of the calculus, then we know that if you take the derivative of the CDF, will give you what? Will give you PDF, right? So the same way you integrate the PDF will give you the CDF, right? So that's what when we end the video, we say this is the most important part we need to know. So the CDF and the PDF's relations, right? So you integrate the PDF, will give you the CDF, and you take a derivative of the CDF, will give you the PDF. Okay, so now let's go back to our lecture. How about now I expand this to more than one random variables? You do the same way. The concept-wise is exactly the same. So let's go back. Let's leave the whiteboard and let's go back to our presentations here. Okay, so we finished all the way. We finished the discrete random variable joint. So let's take a look. Okay, so let's go here. So now we talk about the probability joint density functions, right? So that's what we call this probability density function. That's what we call this the PDFs, right? Okay, so the same way they say, the PDF is a function defined in the XY plane. It's a joint density. So if you have some like the regions here, right? Because if you do the double integration, so you have X and Y to consider. So you really just integrate these inside these regions here. So if the A is here, right? So if you say that A is like from the 0 to 1, and the y is from 0 to 1. So basically, you just integrate, like 1, 1. So you just integrate is, inside these regions here. So then the theory is the same thing as the discrete. That means every PDF has to be greater than 0. Then the second part here is instead of adding all the probability density, so when you integrate, because it's a continuous, will be equal to what? Will be equal to 1. So the joint distribution function, so this is what we call it the joint, the CDF. So instead of just doing the x to the lowercase x, you integrate the both, all right? So that's what we call the joint CDF. Like I said, everything follow the same thing as we did for the one single variable. And so let's take a look at our example here. So in here, I want to mention here is, this is a statistic class. So when we try to do the problem, I'm not going to show you how to do the integration again. I assume you learn how to do the integration in your calculus class. So I'm not going to spend the time just show you the integration skill. I'm going to list what we are integrating. Now, I assume you know how to integrate, right? Because if you come to this class, that means you need to have the calculus background here, okay? Okay, so now let's take a look at number 4 here. So let's say given the joint PDF densities here, this is my PDF, so it's 3/5 xy plus x. And this is my domain, x is from 0 to 1, y is from 0 to 2 here. Then they want to find the probability in these regions here, right? So the region A is 0, x is from 0 to 1/2, y is from 1 to 2. Okay, so just based on what we say, okay, so the probability here, right? So the probability, the x and the y, right, belong to this region is the same thing, just like we integrate. Now I have 2 variables, so I need to do the double integration. So x is from 0 to 1/2, so I put a 0 to 1/2, right? Then the y is from 1 to 2, so I put it here is 1 to 2. And this is the 3/5 and the x, y plus x, right? Because, because here, this is the x regions, right? So what do you need to integrate here? The first layer, you integrate the dx and the dy's here. So for this problem, I will do a little bit, show you what is the double integration. So because in here, take a look here, the first one you integrate is to the variable x here. So you treat the y as a constant, right? Okay, so if you do a kind of a distributive property, so this one will give you 3/5 xy plus 3/5 x squared, right? So when you distribute that. Now let's try to integrate these ones here. So your second layer, we must change it yet. So the first layer, so this is the one you want to integrate. So what is the, remember y is a constant, right? So you integrate to x here. So that means you only integrate to the x here, right? Y is a constant. So let's take a look here. So this is 3/5, right? So the 3/5, so you have the 3/5. Then the x is what? What is the integration of x is x squared over 2. Then the y is still here, correct? Now, then the second one is here. This is 3/5 x squared. So what is your integration for x squared? So it's the x cubed over what? Over 3 here. Now, because they have bound, so what do you put here? So you will put the 0, 1/2 here as your bound, right? Then you still have dy to integrate. Okay, so now you substitute the values and then this will be the algebra. I assume you would do that. So I did this. So if you put 1/2 into the x, so this one will give you, this is the 3y over 40 and the plus 1 over 40. And so this is what you get out by substitute the upper bound minus the lower bound, right? And then this one's here, you take the integration for dy. I strongly recommend you try to carry out this integration and to see you be able to reproduce the same value I do. Okay, now, then the second layer, you integrate two y's, right? So that means you need to take a look at the y's here. Okay, so let's take a look at what is the integrations here. So the integrations here, this will be the 3 over 40, right? So y you take integration is what? Y squared over 2. Then the 40 is a constant, right? So it just be y over 40. And what is your bound here is 2 and 1. So you can just substitute the upper bound and the lower bound. So here it will give you 11 over 80, right? So that's the probability for these ones here, right? So for the x probability of xy inside these regions here, okay? Some of the teachers, they was even allowed you to use some like the automatic integration calculator. You can just plug the number that will give you the answer. The point here is this is a statistics class, right? We're not trying to test your calculus ability, but you need to know how to set it up. But depends on what is your teacher want. Some of the teacher want you to carry out because you assume to know the calculus, all right? Okay, so that's it. Okay, now, so it's not bad, right? So it's the same thing. Okay, let's take a look, the problem 5. So if I have the joint PDF, XY is given below. Oh, I'm going to find the joint what? I'm going to find the joint CDF, right? So I'm going to change the distribution function. That means the CDF is cumulative, the CDF. Okay, so remember the CDFs, right? Okay, so now in here, when we try to do it, I want to, okay, the first one's here, let's take a look at X, this is region, and this is the region of the Y's, right? So in here, let's take a look here. And so, okay, this is X, this is Y, right? And this is the X, this is the Y. And then, okay, so this is the 1, this is 1, right? So here. Okay, so you divide this whole region to a region 1, 2, 3, and 4, correct? Okay, so this is 1, right? Okay, so now let's take a look here, right? So for the region number 1 here, okay, so for the region number 1, okay, so the region number 1, that means it's X is these regions, right? So I'm going to, so based on my CDF XY, what is this ones here? That means I'm starting from what? From the 0 to what? To X, then from the 0 to Y, right? Then instead of using XY here, so I will say S plus T, then the ds dt, right? So this is your PDF. You integrate it to X. That means the X is here, could be here, could be here, right? So that's what is the region number 1 here. And then now, if you take the integration, now I assume you know how to do this integration, right? So we can do one more time. And then, so you take the integrations here. So this is S, right? So you will treat the S is the variables, right? So your integrations here, what it will be? So it will be 2 to the what? S squared plus STs, right? Then you put the 0 and the X here, right? Now you still have the DTs here, right? Okay, now you put the X in there, and so this is 0y, so this will be 2 of the X squared plus XT. Now you take a look at the integrator about the DTs here. Okay, so you integrated the t's here. So the final answer for here, it will be, this is 1/2 xy and x plus y. Like also, I would strongly recommend you, try to verify, the integration. Just try to kind of practice to make sure you know how to do the integrations, right? Okay, so now let's take a look at the region number 2 here, right? So the region number 2, let me put it in here. I need more space here. So the region number 2. Okay, so region number 2 is which region? Is this region, right? Okay, so take a look at this region here. This region, the f of xy, the x is above it, right? It's above the domains here, but y is still, the inside the y's domain. So in here, the f of xy will just be the 0 to y, right? Because y, the yellow one, the y still is below 1. So you integrate the 0 to y, and then what happened to x? X you already integrate, is outside, so should be, so is you integrate what? 0 to 1, right? The whole thing's for x, right? Because x is between 0 and 1, so you integrate 0 and 1 here. Then you have s plus t, then the ds dt. All right, so now these ones here, I already did it. So the integration is 1/2 y plus 1. Okay, so make sure, like I say, this is our example. So make sure you know how to carry out the integration. Like I said, this is a stat class. I'm not going to teach you one more time of the calculus, but from your side, you need to do that just in case, you will need to do that. Okay, let's take a look at the region 3 here, okay? So the region 3, so which region is this? It's this region, right? So this is region 3. Okay, so for this regions here, the y is already 2 to 1, but the x still is in here, right? So I can say the region 3, the f of xy will just be equal to what? And then the x here will be to the x, right? So it's s plus t es dt. Okay, so now follow the same idea. What is the y? Y is this green one, right? The blue one, right? It's already reached the outside of the domain. So what I need to do here, y is just where to where? 0 to 1, right? Now you take the integration, and the integration will carry out to a 1/2 x plus 1. Okay. Okay, now let's take a look at the region number 4 here. Okay, so the region number 4 is this purple regions, right? So the region number 4 here, when you look at this region, both x and y is outside the domain. So I know that means this f of xy is what? You need 0 to 1, 0 to 1, right? Because you already add areas, it's already outside, so you need to integrate the whole domain, so ds dt. So I know from the property, if you integrate the whole domain, what is here? It's 1 here. Okay, so now let's take a look. How do I write it, right? So this is my calculations, right? So, okay, so this is my calculations. So now let's try to write out my final answers here. So I say my CDF is equal to, okay, so will be equal to 0, if x is less than 0, y is equal less than 0, right? Because it's the domain is from 0 to 1. Okay, now then I'm going to have a CDF is 1/2 of xy, x plus y. What is this going to happen? This is going to happen in where? In this region, right? So it's region number 1. So both of them is within the domains here, right? Because both of them is within the domains here, so that's why. So what is here? So this is x is from the 0 to 1, y is from the 0 to 1. Then we can also have a region 3. So we'll say this one is 1/2 y to the y plus 1, right? So what happened to here? So this x is already greater than or equal to 1, but y is still between 0 and 1. Then the other ones here, this is 1/2 x plus 1, right? So this one's here is what? This is y greater than or equal to 1. Then the x is between 0 and 1, right? Then the last one here is 1. So this is when x greater than 1, y greater than 1. So it's a kind of the match what we have in the single variable. If you remember, our single variable, the CDF sometimes they go like this, right? Then they go here. Right, that means that after they exceed their domain, it just be 1, right? So this is 1. That's what is one variable, CDF. So this is the same for the two variables. That is why this is where this one comes from here, right? So for each region, you can see, what you need to do to get it. All right, so this one's here is a little bit kind of so I would say, a little bit hard. And so make sure you reviewed it and make sure you understand that. All right. Okay, let's take a look at number 6 here. Okay, so the number 6 here, right? So they say the probability density, find the probability density function for the x and the y whose joint CDF is given below, right? Okay, then use the probability density function to find, to find what? To find the probabilities, right? Okay, so look here, this is a capital F, right? So if this is a capital F, that means it's a CDF. So remember in one variable, the derivative of the CDF is equal to the PDF. The integration of the PDF equal to the CDF, right? So now I need to find, so what I'm finding here, so I'm finding f of xy, okay? So like if for single variable, you just take the derivative, but now I have two variables, right? So when I have two variables, then what I need to do is here, so I will need to do the derivative twice, correct? So now let's start here, right? So let's say here, the rho f, so if I want to take a derivative, so it's rho f. Now I take the derivative first with x, okay? So take a look at these ones here. If you take the derivative with x, that means y is a constant, right? Okay, so let's take a look. So if you take derivative, so the whole this things here, right? So this things here is a constant because it's y, right? Okay, so now let's take a look at derivative of x. So 1 is cancel, right? So 1 is 0. Then the e to the negative x is what? You have a negative sign from here, so this is negative sign. So e to the negative x, we know the exponential, the derivative always be to self. Then you need to do what? The chain rules, right? So you need to do the chain rule to the top, see here, right? So chain rule will be what? -1, right? So you still have this one, 1 minus e to the negative y, because this is a constant. You only take the derivative to x. So let's simplify this. So this is e to the negative x, 1 minus e to the negative y here, right? So this is after that. Okay, now I need to do another one. So that means that row f of xy, I already did row x. Now I need to do row y's here, right? What means I need to do the row y? That means e to the negative x. So which one is my constants right now? Hey, this one will be my constants, right? So whenever the x here will be my constant. Okay, so now I keep the e to the negative x here. Okay, now I integrate it, I take the derivative here. 1 is 0. So this is e to the negative y. Then chain rule, so it's negative 1. Correct? Okay, so it's a positive, negative, negative, positive. So it's e to the negative x, negative y. So it's e to the negative x plus y. So this is what? So this is the PDF, right? So this is the PDF f of x, y. So of course, x is the same domains here. All right, be very careful, right? So like right now, because you have two variables, so you need to do the derivative twice. So when you do the derivative to x, you treat y as a constant. When you take derivative of the y, you treat the x as a constant. Okay, now they want to find these probabilities, right? So if I want to find the probability 1 to the x equal to 3 and the y to the y to 2, right? Then you can say, okay, I'm integrating. So put the limits here, 1 to 3, right? Then y is 1 to 2. And then what is your PDF? E to the negative x plus y. Because you put the bound here, so you take the integration dx first, and then you take the integration dy, okay? And I will leave this to you to practice your integration. I just want to tell you that the final answers here is pretty close to the 0.074. Okay, so make sure when you finish the video, go back there to see you'll be able to reproduce this one or not. All right. So make sure practice your integration, kind of go to refresh your memories here. Okay, so now let's take a look at this one here. Okay, this is our last problem here. So we say if the joint probability density function xy given below. Okay, so this is x greater than 0, y greater than 0. This is really the trouble ones, right? So this is my domains here, okay? All right, so then the function is f of xy equal to 2. I want to find x less than 1/2, y less than 1/2. Okay, so the first, let's take a look. What is the domain I'm having here, all right? Okay, so let's see here. Okay, so this is the x and the y. Okay, so x greater than 0, y greater than 0. That means in the first quadrant. Now let's take a look at x plus y less than 1. Okay, so let's graph this line. So when x equal to 0, y equal to what? Y equal to 1, right? When y equal to 0, x equal to 1, correct? Okay, so now that means this is our lines, right? So this is the x plus y equal to 1. But then they say it's less than 1. So where is the regions? That means where is my, so here, right? So I know this is my domains here. Got it? All right, so this is my domains here. The yellow area is the triangles, right? Okay, now here I'm going to show you sometimes the integration is pretty hard, and then you want to use some of the tricks here, right? Okay, so now here, so first part here, they ask you, what is the probability x is less than or equal to 1/2, y is less than or equal to 1/2. Okay, so if you take a look, right, so 1/2. So if this is 1/2, and then this is 1/2, so they're going to 1/2, because this is x plus y equal to 1, so they're going to intersect here, right? and become what? And become a square. So that means, your integration area is a square, right? And remember, when we do this integration, it's kind of like you find the volume of the function above it. So in here, this is the area. So my volume, the height of whatever this volume is, 2, right? So it's just similar like in the calculus 1, when you try to find the integration, you find the area under the curve, right? So for the calculus, like for the calculus 3, and when you try to find two variables integration, you really try to find the volume under, under the graph, right, under that curve, see here. Okay, so in here, so in order to find the volumes, right? So this is a square, right? So the volume of the square is 1/2 times 1/2. And what is the height? The height, right, is the function values, right? So function value is a constant. So the height is what? It's 2. So what is the, what is the areas here? What is the probabilities here? The probability is 1/2, right? So it's pretty simple here, all right? All right, so now the second one's here, if you understand, the concept. So now this is a probability x plus y greater than 2/3, okay? So, well, if you really want to use the integration, that's probably will be pretty difficult to do. So let's take a look from the, I erased a lot of them, that's fine. Okay, so here, this is 1/2. Oh, here's good, okay. Okay, so now this one's the x plus y greater than 2/3, right? 2/3. So let's try to first graph it, right? So you said x equal to 0, y equal to 2/3. 2/3 is somewhere here. Y equal to 0, x equal to 2/3 is somewhere here, right? So now you connect it. So this green line, of course, my line is not totally straight, but you understand that. So this green line is x plus y to the 2/3, right? So this is the x plus y to the 2/3, and they say it's greater than. So which area I'm looking for? So I'm looking for greater than, right? So that means above. So I'm looking for this area, the blue area. Okay, so now let's take a look. How do I find the blue areas here, right? So the blue areas here, let's take a look here, right? So this is 2/3, right? So here, if you come up here, 2/3, right? So 2/3, so what is this point here? This is 2/3, what? 1/3, right? So this is a 2/3, 1/3, right? So now you will have here, okay, so this is so let's take a look, right? So so the first things here, in fact, okay, I think that we can do an easy way. So here, no, we don't need to do this way. Okay, so the whole list, right? So the whole list area is 1, right? Okay, so you're looking for this blue area. So this one will be equal to 1 minus, okay? It will be 1 minus what? 1 minus this small triangle, correct? Right? So so the big triangles here, let's try to do this so we don't get confused, all right? Okay, so why is not erasing? Okay, so let's do this, all right? So the big triangle, the area of the triangle is 1/2 base times the height. So it's 1/2, 1 times 1, correct? And then you need to times 2. Why you times 2? The 2 this 2 is the 2 here, right? It's the function values, right? So you need to use your area times the height, right? Okay, so now then you need to minus, right? You minus this little purple triangle. So what is this purple triangles here? Is 1/2 the base times the height, right? So base is 2/3, height is 2/3, then times 2. So the same things here, this 2 is the height of that function, right? So now you calculate that, and so this one will be, well, this is 1 minus, and then this one here is so 4/9. So this is 5/9. Okay. All right. So now let's take a look at the part C here. Okay, so the part C, we want to find the probability x greater than 2y. Okay, I'm going to redraw this thing so it will not be too messy here, right? So here, this is xy, this is 1, this is 1, right? So this is my domain, right? So this is the, okay. Now I'm looking for this x equal to 2y, right? So I'm going to draw the lines here. So x equal to 2y. So when the x equal to 0, y equal to 0, right? So it's in here. Then when y equal to what? When y, okay, so this is the x 2y, right? So when the x equal to, so like in here, if the x equal, so in here you want to find where they intersect, right? So when x equal to 0, y equal to 0, right? So when y equal to 1/2, then the x equal to 1, right? So here, so you have this point. Okay, so now you graph it, right? So this is x minus 2y, and because it's less than, right? So which area I'm finding? I'm finding this area. This is this yellow areas here. Okay, so when you find this yellow area, the first things here you need to find where they intersect, right? So x equal to 2y, you try to solve the equation with x plus y equal to 1. So I find out this intersect here, intersect x at 2/3, y at 1/3. So basically, what I'm looking for here, I'm looking for, okay, this little yellow areas, correct? Okay, okay, so now I'm looking for this little area. So what is this areas here? So we know it's 1/2, right? So the areas here, this is 1/2 times what? 1/2 the base times the height. So what is the height? It's 1/3. Base times the height, right? So it's 1 times 1/3 and the half because it's triangle. But then also I need to times what? I need to times 2, so, right? So I need to times 2 here. So now why is 2 here? So remember the 2 here is the PDF value. So now the answer is pretty simple. So what is the answer here? It's 1/3. All right. So the problem number 7, they tell us a different way. It's kind of like just looking for the area under the curve for one variable, right? So now for the 2 random variables, that means it's a double integration. So double integration basically is find the volume. So in order to find the volume, you need to have a base area times the height. So base area is those like the yellow triangle, those blue things, purple things. Then the height is the value of your PDF here. Okay, of course, here you can use the integration to find this, but it will be pretty kind of tedious. But if you like, you can check it with integration to see that is correct or not. Okay, that's it. And I know this is a little bit kind of harder than what we did previously, but that's what I said. PDF CDF concept for the single random variable is super important because you expand the same idea to multivariate, right? Okay, so that's it for this video. Our next video, we're going to talk about other things. We're going to talk about the conditional distribution. Right now, because we have two variables, then just like we talk about the independence things, we have two variables, we can see what is the conditional distributions here. All right, so that's it, and have a good day, and hope this will not overwhelm you, okay? Okay, bye, talk to you later, okay, bye-bye.